Applied 30S. We are going to talk about deductive reasoning today. So you need to be on page 20 in your booklet. So deductive reasoning. Let's consider the following conjectures. All teens like music. Can this conjecture be proved? Well, so far the problem with this conjecture is the word all. How are you going to prove that all teens like music? Let's think about this. How many teens are in the world? And what do we classify as a teen? These are all things you need to consider. So, can this conjecture be proved? No. All right, so a couple definitions. Proof. A mathematical argument showing a statement is valid in all cases or that no counterexample exists. Needed to prove a conjecture is true. A demonstration using an example is not a proof. Generalization. A principle, statement, or idea that has a general application. Transitive property. If two quantities are equal to the same quantity, then they are equal to each other. If A equals B and B equals C, then A equals C. Deductive reasoning. Drawing a specific conclusion through logical reasoning by starting with general assumptions that are known to be valid. Let's start with some examples. John discovered a pattern when adding integers and claims that whenever you add 5 consecutive integers, the sum is always 5 times the median. Can we prove John's conjecture is true for all integers? First, let's start off with a couple of words. Consecutive. Consecutive, in a row or order. So they follow 1, 2, 3, 7, 8, 9, 22, 23, 24, 25. Consecutive. Who remembers what median means? So the median is the middle number in a data set. So they have to be in consecutive order in order to figure out what your median is. Let's take it back to stats. So in our first one, 1 plus 2 plus 3 plus 4 plus 5, the middle number is 3. So 3 is your median. If you go 3 times 5, it equals 15. In our second one, 13 is our median. 13 times 5 is 65. Negative 1 times 5 is negative 5. So, do you think we can prove that his conjecture is true for all integers? So there we went over. The median is the middle number in the data set. But let's try some larger numbers. So 210 plus 211 plus 212 plus 213 plus 214 equals 1060. 5 times our median, which is 212, equals 1060. So it still holds true. Therefore, we have no counterexamples. So, proof. Let's use variables and try and prove that we could put in any 5 consecutive integers. We can use an x as a median and we'll write a generalization for the sum. So sum equals s equals x minus 2 plus x minus 1 plus x plus 1 plus x plus 2. Simply by gathering like terms, we come up with 5x. Since x represents the median of 5 consecutive integers, 5 multiplied by x will always represent the sum. We have created a proof showing John's conjecture is true for all integers. So, let's try our next one. Prove that when two straight lines intersect, the vertically opposite angles are equal. For example, we'll try using two-column proof where one column is for statements and the second is for justifications of each statement. So, statement. Angle 1 plus angle 2 equals 180. Those are supplementary angles. Angle 1 equals 180 subtract angle 2. Subtraction property. Angle 2 plus angle 3 equals 180. Supplementary angles. Angle 3 equals 180 subtract angle 2. Subtraction property. Since angle 1 equals 180 subtract angle 2 and angle 3 equals 180 subtract angle 2, then angle 1 and angle 3 are equal. Use deductive reasoning to prove that for a two-digit number, you can add the digits, and if the sum is divisible by 3, so is the original number. So let's focus on the numbers we know are divisible by 3. 9, 24, 27. So 0 plus 9 equals 9. 9 divided by 3 equals 3. It works. 2 plus 4 equals 6, and 6 divided by 3 equals 2. Works. 2 plus 9 equals 9, since we've checked this one already, because divided by 3 equals 3. So proof. Let AB represent any two-digit number. A is the tens, B the ones. AB equals 10A plus B. So for the 24, 10 times 2 plus 4 equals 20 plus 4 equals 24. AB, 9A plus 1A plus B, same as before. 9A plus 1A equals 10A. AB equals 9A plus AB. The number AB will only be divisible by 3 when 9A and AB are divisible by 3. So the divisibility rule is true. Alright, so more examples. All dogs are mammals. All mammals are vertebrates. Shaggy is a dog. What can you deduce about Shaggy? Well, I can deduce that since I can deduce that all dogs are vertebrates. So, Shaggy is a vertebrate. Alright, so let's prove the following conjecture. The difference between consecutive perfect squares is always an odd number. Well, first, let's try a couple. So, consecutive, meaning in a row. Perfect squares, so that would be like 2 times 2. That equals 4. So 4 is a perfect square number. It would be 8 times 8. That kind of thing. So, far, the conjecture is proved right, but now we have to prove it. Okay, so now that we know that so far we have evidence to back up the conjecture, let's try and prove it. So, proof. Let's let 2n plus 1 represent the odd number. Okay, our next step, let's expand it out. Okay, now let's combine like terms. Now, let's factor out. So, I grouped like terms that had a factor of 2. Since 2 times any number is even, the square of an odd number will always be an even number. Plus 1, we get odd. So we have proved our conjecture. So, let's try this one. Terry claims that any 5 consecutive integers placed in a V shape below can be arranged in a way that both arms add up to the same sum. Create a proof that proves her conjecture. So let's try it with the numbers 1 to 5. So it works for that one. Let me try another one. So that equals 36. What I want you to do now is I want you to pause the movie and I want you to create a proof. So mathematically prove that this can be done. I don't want examples, I want a proof. What I want you to do is I want you to complete that and then we're going to go over it in class. Let's try this one. Alex thinks that Terry's conjecture and develops his own for any 7 consecutive integers can be arranged in a Y shape below such that the difference between the sum of the small arm, 3 numbers, and the large 5 numbers will be 2 times the median. Create a proof that shows this is possible. So remember, median is the middle number. So let's use the numbers 1 to 7. So our middle number is 4. And since the difference has to be 2 times our median, that means our difference has to be 8. So I proved that it was possible, but now I want you to create a proof again. So I want you to create a mathematical equation that proves that this is possible and bring it to class tomorrow. Then your assignment is to do page 26 and 28. Have a good rest of your day.